Hey everyone, let me just check that my stream works. Oh no. Yeah, I will have to rename the stream. I'm calling it high cardinality features, but it will be actually LeetCoding problem. Sorry if you have expected a different thing. I will have to rename it in post-production. Now, let me jump here and let me start solving this problem. Okay. So we are given an integer array R, list of integers. For some starting index, you can make a series of jumps. The first, third, and fifth jumps in this series are called odd number jumps. And okay, these are called even number jumps. Note that the jumps are numbered, not the indices. You may jump forward from index I to index j in the following way. Okay, so during the odd number jumps, you jump to the index j such that array of I is smaller than array of j, and array j is the smallest possible value. If there are multiple such indices j, you can only jump to the smallest such index j. Okay. And during even number jumps, you jump to the index j such that the array I is bigger than the array of j, and array j is the largest possible value. If there are multiple such indices j, you can only jump to the smallest such index j. Okay, so on odd number jumps, we are jumping to the smallest of the bigger values, and vice versa on even number jumps. It may be the case that for some index I, there are no legal jumps. You jump to the index j such that, okay, it may be the case that for some index I, there are no legal jumps. What does it mean? So for example, here, if on the odd number jump, we need to jump to something that is the smallest possible value that is bigger than the current value. So if we are already at the biggest value in the array, then we cannot make an odd number jump. A starting index is good if okay, so we are returning the number of good starting indices. Okay, fine. We are returning an integer, and I will write some tests, but first let me also mention some challenges. So cannot do an odd jump from the biggest value even from the smallest. Okay. To reach starting index, okay. Another constraint that I didn't understand and then it didn't make sense was that I is always smaller than j. So we are always jumping to the right side of things, and we need to reach the end of the array, which is a very specific number. So we have number at the last index of the array, and we need to jump there, doing jumps to the right until we reach it. So then we need to figure out how, from which indices of the array we can do this jump. Okay. And we need to start jumping with an odd number jump because this will be the first jump. And so we will be jumping to a bigger number on the right and then to a smaller number on the right. And then to the bigger and then to the smaller, but it will always also be the biggest and smallest possible value. Okay, one observation. Let me make it part of the solution. If you can reach index, if you can reach end of the array from index k, and you can reach k with the right jump, you can reach the end of the array. This will be an important part when we start solving the problem, but before we do that, let's write some tests and another challenge. Always jump in to the smallest possible, biggest possible. So let's first start with something like 1, 2, 3, 4. So we want to reach number 4. Let's say we start with 3. So on 3, we need to do the first will be odd number jump. So we are jumping to a bigger number. So from 3, this works, right? Because we can jump from this to the smallest available number bigger than our current number, and this will be exactly 4. So we can reach from number 3. What about number 2? So if we are making an odd number jump, we need to jump to a number, the smallest one out of the available ones to the right, and then the smallest one to the right will be 3. So we will do an odd number jump here, and then we will do an even number jump to the element that is the biggest, that is smaller than the current number. So from 2 we cannot reach 4 because from 3 we don't have any even number jumps possible. Now what about 1? So from 1 we have to jump to 2, which is the smallest bigger number on the node jump. Then we need to jump to a number that is smaller than 2 and to the right. So we don't have numbers smaller than 2 and to the right. Then for 1 it will also be false. So then the answer for this, okay, also from 4 we don't need to even make a jump, possibly 0. So we are also returning true. So the result is that there are 2 indices that are starting index is good. Yeah, there are 2 good starting indices in this array. Obviously there can be like duplicate numbers, duplicates and negatives, but it doesn't change our structure at all. So it means that for each number we will need to store, if the next jump is even, can we is it a good index, and if the next number is even, can we reach the index, and if the next jump is odd, can we reach the end? So basically, then we will be reaching those numbers. We have deterministic way. Oh yeah, what if there are two possible indices? This is what if there are duplicates, right? Two. Because what I'm worried about, right? If we have duplicates, let's say we have 2, then 4, then 2, then 1, I don't know. But essentially it can be that both of these two are suitable. Let's say we have also one here. So both of these tools are suitable as the destination for this one, because both of those are the smallest ones. So we don't have a unique smallest one. And then the question becomes, which one should we choose? So duplicates is a question that I want to ask. And then indices, yeah, we can have duplicate indices. Then it complicates the problem a little bit for us, because now we need to choose also like which particular index. But yeah, then we have duplicates, and for each of the duplicates we can have whether there is at least one duplicate, which is a good starting index for the correct even or odd jump, and then it would work again for us. So okay, this works. I won't calculate the number of starting indices here, but overall this problem is understandable. Let's now think about how we will be solving this, right? So we will be storing odd, which will be an array, and even, which will be an array. And then we will start with the last index, and then we will be figuring out for each index what is the smallest available odd and what is the smallest available even number that is on the right side of our element that we are considering right now. So then for each of those we will have like a specific index in this odd and even arrays. And what we will see, right, for any number we will see what is the smallest what is the legal jump that we can do from here. And we will know that this is like, if we use this as a starting index, the first jump is always an odd one. So then we will be looking at an even numbered arrays. And yeah, so we will have to store also, like, we will start with an odd jump, but then when we traverse the array again, we will have to store both ways, right? Like basically if it's an even jump or an odd jump, just because when we will continue going over different numbers in the array, we may encounter the numbers that will need to consider this particular index as an even jump, because it will be like an even jump. I don't know if that's clear. Basically, if we are considering this too, this will always be, the first will be then an odd jump, right? And we'll make it and we will decide if we can make it or not. And then if we just consider the odd jump, we will not know what happens if there's an even jump from the two. So now if we consider both of those, we will be able to see, okay, what, for example, if we start with 4 and we do an odd jump there, whatever, whether it's legal or not, then from here it will be an even jump. So here we will be looking at all the numbers on the right of the array. And if we do an odd jump from 4, we will be looking for valid next indices for odd. Otherwise, we'll be looking for valid indexes for even. And then for all such indices, we will be figuring out whether there is at least one that is valid to get to the end of the array. And if there is such an index, then we populate that it's also a valid index, valid starting index for this particular place in the array. And then once we finish, we just summarize, do a sum over our odd array, and it will be the total number of good starting indices. So essentially the solution that we are proposing will be a dynamic programming one, and it will be the most sophisticated part here will be storing those next smallest and next biggest indexed. We can obviously do that in O of n log n time, but is there a better way? No, because we don't know, like we may have to consider, I don't know, number 10 here, right? And if we consider number 10, it will be a very different situation than if we consider minus 10. So for both those options, we will have to choose very, very different possible next valid stops for odd and even. So we will have to store all the possible values and their indices in the array. But do we? Yes, we need to store the indices because for indices we will be storing odd and even values in those two arrays. So what do? On each iteration, we find the smallest value bigger than this one for an odd jump, and biggest smaller value for an even jump, and then select whether among several such values of possible duplicates we have at least one that is a good jump. Okay, smallest, that is, oh, smallest, smaller or equal, that is also important, right? So we can also choose the same value, not necessarily smallest bigger one, smallest bigger or equal one. Okay, so then on each iteration we will need to update, we will need to add a new element here. And how we will be adding this element? So we will be adding the element we can just also store odd and even now values together with this. So instead of storing like everything in the array, we can just store everything in the dictionary. But yeah, I think arrays is a little bit easier to figure out. And then the only problem will be that if we have many indices in such array, we won't be able to quickly figure out. Okay, so if we have many duplicates, we find the indices for all these duplicates. Let's say among all of those duplicates, there is just one value that is a valid jump. We have to iterate through this whole thing to find this one value. And that is good for us. We found that this index is valid now. It's a good one, the starting one. But the problem is that we had to iterate up to O of n positions for that. And because of that, we cannot really, at least I don't see how we can store this on the even values. I think we will instead just store a dictionary. So instead we will be storing a dictionary of value, and then it will be storing like even boolean and odd boolean. So this will basically mean that if we are trying to do an odd jump, and this will be a sorted dict. So we will find we will bisect keys of this sorted dict and find the value that we need, that is the smallest bigger one, and then we will see whether there is like a valid odd or even jump. And then if we are updating a value in this array, if it's already in the array, then we are updating, like we need to just find one valid value. So if some of those is false and now the new value for this specific new validity for this specific value is true, then we can update this, and like basically it will be or relation between different duplicates. Okay, we have spent 20 minutes on this, but we have done this part, and I think we are ready to implement this. So yes, it will be of n log n solution, and it will take of n space implementation. Values equal valid starts equals 0. Okay, can our array be empty? I think let's just say the answer is here. Okay, if not array return 0, just to process the possible corner keys, then valid starts equals 0, values equals sorted ticked. And let's say 1 and sorted ticked, which will be, we will already have a dictionary where we will have a value of the array -1. We ensure that it exists. And then array -1, and it will be pointing to another array. Let's just point it to tuple. So tuple will be if you reach there and the next jump will be odd, it's fine, you have reached the end. And if you reach, if you need the next value to be, jump to be even, it's also valid. So however you arrive in the end, whatever you need as the next jump, you have arrived, you can assume that this is a valid result now. Okay, so values is this. Now array pop while array. So value equal array pop. So this is the current value. Now we need to assume, like, what if we are doing odd jump and then even jump? So next value equals do we have, yeah, I think will be something like sorted dict find. Let me see, sorted dict find. Do we need to do bisection, or do we already have Python sorted dict? Let's see. Okay, so finding the minimum key and corresponding item. Finding the maximum key and corresponding item. That's not what we need. So we have bisect. And target key is not amongst the current key set. Okay, so I think what we need is this, right? Let's see, sorted it, bisect. Bisect left returns the index where the key would be inserted to maintain sorted order, such that it would be on the left of any existing entries of the same key. And bisect right key, it returns the index there the key would be inserted, such it would be to the right of any existing entries of the same key. Okay, so the problem that I'm currently encountering, right? We want to do a binary search over the keys, but we want to be very mindful of the situation where we have the situation is that we are looking like if there is such a key in the array or not. So if there is no suitable key in the array, we want to return we know that there might not be a valid jump there. But okay, I think the easiest way to approach this is to use bisect and pick item. Okay, so first of all, if we are doing an odd jump, so odd jump should be done to a value that is bigger or equal. So if values, then should I call it nums? Yeah, I think let's call it nums, because values are also part of the dictionary and it will be complicated not to mix it up. Okay, so if num bigger than nums keys max nums keys, so I think it should be all one operation. Then we can say that is valid odd is good. Let's call it good. Good starts, not valid starts, right? Odd is good equal false. Else, if it's not bigger, then what is the biggest item? The item that is the smallest one that is bigger or equal to. So then what do we need? We need to have, first of all, we need to bisect. So item index will be nums bisect, and then bisect right or bisect left. So let's read again, right? Bisect right, where the key would be inserted such that it would be to the right of any existing entries of the same key. So actually it doesn't matter, right? We just need to find what is, but we need to find pick item. Sometimes we'll be picking the next item, sometimes we'll be picking the previous item. So how does pick item work? Okay, so this is the, so here we are given an example, fortunately. So here we need to find the smallest that is bigger than, so it will be this sort to dict pick item, sort to dict blah 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 target. Let's insert it here. So in next num so next even is valid. So here we will be getting the next value. We don't care about this. Here we will be getting the next we will be getting the next value if the next jump is even odd here, but since this is an odd jump, the next jump needs to be even, and we are getting it here. So now we will just substitute it for that, and then we are done. This is all is good. Then even jump. So even jump if num is smaller than minimum nums keys. Even is good. Else we do pretty much the same thing, but here we do even is good, and bisect left target, but here we need to do -1. Okay, so here is how you use sorted dict to pick item at specific index. Okay, now we need to store. What do we need to store? We need to store, okay, if nums of num is equal, okay, if num in nums current odd is good, current even is good. So if we see a duplicate value, then we just do num. I'm thinking, well, if we have a duplicate, we can treat it as like, if we have a duplicate, we always can just jump there. But it's basically a question of where we do this processing of duplicates. We can do it here at this level, or we can do it earlier, because if we have a duplicate, we can always do an even or odd jump to any duplicate. So if any duplicate is there, we can just use its values for odd is even, odd is good. Let's actually do it like this. I think it will be cleaner. Because we will always have to jump there. We cannot jump to any number, any other number, whether it's an odd or even jump. If num in nums, continue. Oh, okay. So here we need to do good starts plus or equal the nums, num and 0, and we do it as an integer. So if num and nums, then we have to jump there. We just have to jump there. And we cannot update anything. Like whatever happened with the last duplicate that we have on the array, the same pattern will have to all the previous duplicates. We will always have to get there, however we jump, because it will always be the smallest bigger or equal value and the biggest smaller or equal value. So then we just need to update the good starts. If this duplicate is a good one, then this other duplicate that we are considering will also be, will it? Actually, no, right? We might have to do an odd jump to there, and then the duplicate might be an even one. So yeah, we might actually update our values for duplicates. So if we have several duplicates, let's say we have 3 duplicates, then once we consider a new duplicate, like the third one in the row, or the closest one to the start of the array, we can always do an odd jump or even jump. We can achieve the rightmost duplicate with any jump that we want. Okay, so then nums num will be, we will need to process it a little more. If num in nums, we do current odd is good, current even is good, and we do it nums num. So we already have this value, this is duplicate, and then it means that odd is good will be equal to odd is good, or current odd is good, and even is good will be equal to even is good, or current even is good. And then nums num will be equal to odd is good, even is good, and then finally we do not that, but we do good starts plus or equal integer of what is good. So we start here, we have to do is an odd starting jump, and if it's good, then we can achieve, then get to the end of the array. And we just return good starts. Okay, let's see how it works. But let's do a duplicate. Let's do here. Okay. It will be another example. So let me just put it here first, and then update it like this. And let's see how it works. So if not array, return 0, we do have an array, and then our sort now will be that for it will be good is that is good. Oh, sorry, that is true, and both are true basically. So then we remove it from the array, and it will be only the first 4 numbers. So let me just put it 1, 2, 3, 2. We have already popped the array. So num array pop, we pop, and it will be 2. So odd jump, if num is bigger than number of maximum keys, no, it's not, it's smaller. else? So we need to find, so first of all, we bisect left of the target, and we are bisecting over keys, so we are finding the position. So position 0 will be where we need to insert, and then we are looking at that item that is the closest one to this position, which will be like this item 4. So this item 4, okay, we have spent 40 minutes now. Let me just set the timer 1, hopefully last time. So now if we are looking for an item, that is the bigger one, so we will have 4, and we can do a jump to 4. So now we have odd is good is true, and number is smaller than minimum of nums keys. Yes, so even is good as false. So basically we will store that for 2, and 2 will be a smaller one, so we store it here because it's a sorted dict. So for odd is good and even is not good. Nice. We pop another item and we see a 3, and we, oh yeah, good starts becomes 2 because we now have 2 such values where the odd is good. Now good starts 3, considering, okay, if number is bigger than maximum of the keys. No, it's actually here. So odd is good, sorted dict. We are sorting dict and we're finding the smallest bigger value, and it's 4, which is good. And we figure out that odd is good is oh no, here this was a mistake. Even as good as the here. Yeah, so odd is good is the right value from this 4 here, and now odd is good. Now we do another jump. So here we do minimum nums of keys. Now it's not smaller, we have 2. So now we are searching for this, and we are taking an item to the left, and now we take 2 because of that. Yeah, what if we are finding the exact right value? It looks like we need to process it because here we will be returning something smaller than the right value. This is a bug. Okay, so let's copy it here. So the next item, we can do a jump. So we will always have to jump to the next duplicate value. So if we have a next duplicate value and the order is good there, that's what I'm not seeing. Let me just write an example so that we can reason for this together. So here, this is obviously true, right? Then here, this one is also true because, okay, let's do here, let's say it's 3. So here it's true for odd, but if we do an even jump, we don't have anything, so we say that this is false. Now we have to jump here, from here to here, and the odd value will be true, but here the even will be false, so here that will be false, but here we are jumping and it will be true, right? Okay, and this is actually correct. But now here, yes, the problem is, what do we do now? So we now need to take any of those values, because for this particular thing, we are not just adding this number to be another start. So here we're not adding this value, but we now, when we encounter a new 2, it will be true for both cases, because we can do an odd or even jump. We just choose which 2 we want to jump to. Fine. So now the pattern will be what? The pattern will be that so the logic will go like this. If num and nums, then it means that we already have visited this. So then if we are doing an odd jump right now, if nums num then we do starts with starts +1. So it means that we have already seen 2 duplicates. And when we are seeing the second duplicate, we can just update that nums num is equal to true. So starting at this moment, we we can always, when we encounter the first duplicate, okay, here we still need to check what's going on. Okay, so how do we do that? So the first, no, it's not as easy as this. So next, how do we call it? Yep, let's process it here. So current odd is good. If current even is good, then it starts plus or equal 1, and so what if it's false false for both? It is good, current even is good. Even is good equals current odd is good. Not necessarily. Okay, so first of all, we check where did I wrote that? Okay, that was accidental. If num and nums, that is it. So now starting good starts plus or equal 1, and then this. Here's our update. Okay, and here, this is if num and nums. We are updating in a more straightforward way. And here, else. We do that, and we remove that. Okay. Yeah, I think this is it, because I don't want to spend more time on this. Sorted dict is not defined. Oh, yeah, because it's not sorted dict that we are using. Sorted dict is nums is what we are using. So sorted dict. Yes, we also use it here, nums, and here, nums. Okay, we don't use it anywhere else. Target, obviously, another thing that we haven't defined. We are not looking for a target, we're looking for a num. Okay, and this is still incorrect. And I'm guessing this is incorrect because of the duplicates, right? Because our output is 5 and we expect it to be 3. So something's wrong about our duplicates. Yeah, this is incorrect, right? Because we didn't want to update this. When we were thinking about this, we don't want, for this second true, we don't want to update it to be both. Only after this, we want to update it to be both true. So, but this is legit because we are first getting good starts and then we are updating this. Then it looks like, yeah, already here we will be updating, right? That odd is good and even is good already on the second duplicate, and here it's not. We should be first swapping the values. Okay. So when we see the first one, if it was false false, the second duplicate will be false false. If it was true false, then the second duplicate will be false true, then it will be true true. So if it was false true, then it will, on the second it will be true false, then it will be true true. If it was true true, then it will be just true true. So that's the pattern that we want to follow, and unfortunately we are not following these two patterns in our code. How do we follow these two patterns in our code? I don't see a way to do that unless we start storing one. So inelegant, but I don't know how to go about this otherwise. I don't want to store all the possible values and go over all the possible values. Is there a nicer way to write this? Okay, so this should be the correct thing. Now one. So here we are not using counts. And num equal count. Okay, that's better, but still not correct. And I digress. Here I will not continue anymore because I have spent an hour. I obviously didn't solve it in an hour. That was another hard problem. Now I already don't know where the issue is. I bet it's still somewhere in those like duplicates. I hate those duplicates because we have to create a separate processing logic around those. Yeah, but all right, I will see you hopefully later today. Thanks everyone who is watching this, and bye.